Hi there, this is Jacob Nash, and this is going to be the first of many review videos. Well, not many, but like a few review videos. Um, Now, as you can see, I kind of have a strange setup here. Um, I already made these videos a few days ago, and they had no sound for some reason. So or it was actually all in one video, but this time I'm going to just make separate, smaller videos. But Yeah, sorry about that if you happen to see the video and you're like, oh, there's no sound. But so I decided to do a different setup, but as you can see, the video, I have my phone up here, um, recording video, and then my computer's recording audio. That's the only way I could do it. So it's not going to be completely lined up. Like it's going to be the video is a little delayed. So sorry about that, but that's the only way I can do it. Um, Now, the first thing that we're going to go over are just kind of some of the general good guidelines. So remember, when you're doing anything with limits, you should always remember to write the LIM as you go down. Um, so like every time you're doing something, so let's say if something like this, I don't know, you're doing something like this. As you go down and solve it out, always just write this. And if you ever cross anything out, you write X doesn't equal 2 or whatever it happens to be. So that's a very important thing. I'm gonna try to move some stuff. So it's kind of hard for me to. That's a little better. Okay. Now, another thing, you know, this is going to be a little bit tilted. I apologize. Let's see. Never write equals doesn't exist. If your answer is does not exist, you just would write just D and E. These are just some kind of basic things to just save you some possible points that could get taken off. The next thing is whenever you're writing derivatives or integrals, just remember to correctly do things, write your ddx's where you need to. And then remember the integral always comes with dx or d something on the side. That's part of the operation, so you can't forget one of those. Another thing is we have many theorems that we've talked about, and you need to I'll just say, always say by whatever theorem when you're proving it. So if you use squeeze theorem, if you use the fundamental theorem of calculus, you use I don't know, Rolle's theorem, any theorem, that's what you always need to say. It's very important. Now, next I'm going to say are two sneaky test taking uh, tips. So the first is a simplification cheat. So for simplification, now this might not work for all professors that you might have or teachers, but for the most part, um, if you, let's say you're, using the Pythagorean theorem, and then you have like, all right, C is the square root of B squared minus A squared, or plus A squared, sorry. Um, you should logically be able to just leave it like that without actually solving it out. And that will save you some time, and also if you don't know what something is. So let's say you might just be able to say the answer is this, you know, and you shouldn't have to solve that out if you don't have to. I mean, if you don't want to, basically. And then the next thing is multi-part dead end cheat. So what I mean by that is if you have a question that's like this, it has like multiple parts. Let's say you're at part A and you can't figure out the answer, and your answer in A is going to be used in the other parts. Well, if you don't know how to solve A, you don't want to not get any points on the rest. So you just make up an answer. So, okay, X equals 2 or whatever it is, and then you just use that in the other. So you'll at least get half credit. So that's a good thing to do. All right. Next thing I'm going to say is some formulas that you'd need to memorize, or just general things. So you're going to want to know your unit circle. It's not a formula, but knowing your unit circle will definitely be helpful because there might be times when you will have to know the unit circle to solve the problem. Then a good formula to know is the distance formula. This could definitely be used in a related rates problem. So remember, distance is the square root of x 2 minus x1 squared plus y2 minus y1 squared. Just like that. Um, very good formula to know. Then, of course, you'll want to know your Pythagorean theorem. A squared plus b squared equals c squared. You'll want to know your SOHCAHTOA. Oops, sorry about that. SOHCAHTOA. Um, and then you'll want to know for the optimization problems, all your area and volume problems for rectangles, circles, triangles, any shape like that, 2D or 3D. Not hopefully not any other ones like trapezoid or something. But if you think about it, you might be able to just figure it out because trapezoid is like you can think it's just pretty much this. No, that's not right. Sorry. You know what I mean? So you could kind of figure it out if it was a different thing. Um, okay. Uh, just also a general thing, read the questions carefully. Um, you don't want to get a question wrong or get points taken off just because you missed something, because they will try to, put something in there that will make you get it wrong. That's a common thing. So the next thing that we're going to do are some other things you're going to want to memorize that we did learn in the class. Now, I don't know where I put the paper that I was going to use. Let's see. Sorry about that. Um, oh, oh. So you'll want to memorize all of your derivatives and integrals. So let's go over this. So start with the derivatives. It's going to be slightly tilted. I apologize. All right. ddx. So if you take the derivative of a constant, what do you get? That's always going to be zero, no matter what it is. And a constant meaning it's just a number. So if you have, what is the derivative of 2? 5. What is the derivative of pi? What is the derivative e? Any of those things. They're just numbers. Then what is the derivative of a constant times a function? It's just the constant can just still be multiplied by the derivative of what the function ends up being. Let's here if I can make this better. Oh, I have no clue why I just clicked, but happy birthday. I don't know what that is. Okay. Now, what happens if you add or subtract functions? You can still just do that with the derivatives of them. But it's if you remember, it's not the same for multiplying or dividing because we have rules for that. So if we multiply two functions, I'll just say fg for now, okay? Fg prime plus f prime g. So you just do the normal thing times the derivative of the second thing, derivative of the first thing times normal thing of the second thing. Then if you have it divided, a little bit trickier, but a good way to remember it is low d high minus high d low divided by g squared, and off we go. Yeah, didn't come up with that one. Okay, then so that was called, those two were the product and quotient rule. This one is called the chain rule, if you remember. What if there's a function within a function? Oops. Then you just do f prime with the normal function still in it times the derivative of the second thing. This one is easier to tell if you have an example. So if I have sine of x squared, that's a good example of when you would need to use the chain rule, because I do first the derivative of sine, which is cosine, and I leave that x squared in it, and I multiply it by the derivative of what's inside it, 2x. So you use the chain rule usually if you have trigonometry things or even things in exponents sometimes or just parentheses. Okay. The next, which I just used, we have a power rule. You put that exponent beside it and then you subtract the exponent by 1. So if I have x to the 47th derivative or ddx, I'll do 47x to the 46th. That's how that works. Once again, let's say they gave you something like this. X to the, I don't know, like pi over 27 or something like that. Like, let's say you were like, oh, I don't know what pi over 27 minus 1 is. I mean, you should be able to leave it as that, and that should be correct. Okay. Now, let's see. Some of the other specifics. Derivative of e to the x is just e to the x. Derivative of b to the x, where b is something, just a random number, is ln of b times b to the x. Now, a little thing about these two. This one is actually ln of e times e to the x, but ln of e is just 1. So that makes it, that's why it's just e to the x. Right? Now, let's do our trigonometry ones. Sine of x gives us cosine of x. Derivative of cosine of x gives us negative sine of x. Derivative of tangent x gives us secant squared of x. Derivative of cosecant squared, or sorry, cosecant x is negative cosecant x cotangent x. Derivative of secant x is secant x tangent x. And then derivative of cotangent x is negative cosecant squared x. These are 6 friends that you'll want to know. A trick is that all of the c's, cosine, cosecant, and cotangent, are negative. That is a very good thing to know. Now we'll do the other 6, which happen to be the inverse trigs. Which, remember, you can write as, if we're doing this, that's the same thing as arc sine x. I'm just going to write arc sine, because sometimes people can get confused with the -1, so I'll just write arc. So all of these are going to be our arcs, which mean inverse, meaning that it's just the reverse. So like if you do arc sine of sine x, you get x. That's what that means. Arc sine, arc cosine, arc tangent, arc cosecant, arc secant, arc cotangent. Well, x. And what do we get? Well, the first two look pretty similar. Well, for all of them, they're all fractions. That's a good thing to remember. They all have ones on the top, and the ones that start with C's are negative. All right, that's a good start. And then these two look similar. They have square root of x, or square root of 1 minus x squared, square root of 1 minus x squared. So they're the exact same except for cosine 1's negative. And then these two are similar as well, cosecant and secant, and they have x square root of x squared minus 1. So these are the same two. And then these ones look the same, and they're just 1 plus x squared. So these are things that you'll want to remember. So that's all the derivatives. That's pretty much all the derivatives that you would want to know. Uh, there's actually one more. Derivative of 1 over x, or sorry, ln of x. That one gives us 1 over x. All right, now the next things to remember are the integrals. Now remember your plus c for all of these. Now what does that mean, plus c? It's because you know how when you take the derivative of a constant, it equals 0? Integrals are supposed to be the opposite of derivatives, but how would you account for those things that disappear? We just write plus c because it's like there could be something else. So let's start out with, what if we have the derivative of a constant? That's going to be that constant. You put an x with it, and then plus c. So that maybe c wasn't a good letter to use. Let's just do k, derivative of a constant, kx plus c. So if you have integral of 2, it would be 2x plus c. Now, what if you have, that's completely sideways. The integral of a constant times a function, that's just going to be, it's still going to be there beside it. And I'll say again, without writing it, that if you do the integral of two functions that are added or subtracted, they end up, you can add or subtract them. If you have multiplication or division, you're likely going to need to do U substitution. Now, if you have this is like the reverse power rule. It ends up like this. Oh, okay. So sorry about that. I don't have a very good setup here. But that's what we have here because you end up adding the exponent. Um, then I'm not going to go through the trigonometry ones because they're just the opposite of what you saw before. But there are some notable ones. You have this. It's going to be ln absolute value x. Don't forget that absolute value. Then if you have this, it's still just e to the x. Then if you have b to the x, it's going to be 1 over ln of b times b to the x plus c. And I can't think I'm doing this so fast. If I just, for the e to the x, it's e to the x plus c, not just e to the x. I don't know if I wrote that correctly. And that's pretty much it. That's all the main ones that you'd want to know. So another thing that's good to remember is this. That's just something that you'll want to memorize. And other than that, everything else is just, process. Do you remember the process? But that's all the things that you pretty much have to memorize. So that's it for this first introductory review video. Next, we'll go on to 4 different videos where we briefly review all the units and keep in mind, I'll try to make it brief because I've already had other videos like that. This is just supposed to be for the final exam review. So thanks for watching.